All right. Good morning. This is Monday, the 24th for KAP students. We have a warm-up, just a little refresher from last semester, positive and negative numbers. Okay, on this first one, my answer is 9, positive 9. Remember, you can think of it as the teams of the positives versus the negatives. You want to know which one's more. In this case, it would be the positives. How many more? We would need to do what operation at the end? You would end up subtracting. Very good. Okay. On number 2, 11 minus 70 is negative 59. Very good. How else could I look at that equation? That's what I'll talk about another way.
So I don't know, but the way.
Say what you're saying.
So I was gonna say that I changed it to 10, and then like I subtracted from that and
Okay.
added 1.
Yeah. You're talking about the numbers, but I'm talking more about that equation. What was another way that I could do it?
You keep the first number plus negative 90.
You keep and add the opposites. Y'all remember that? Okay, so it would be 11 plus
Negative 70.
negative 70. And then you can go back to those rules of who's winning, in this case, which team?
Negative.
The negatives, and how much are they winning by? 59. Okay? Alrighty. Next one, I have decimals, but it's the same rules. Who's winning, positives or negatives? Positives, and to figure out how much more we need to subtract. When I do this subtraction, what's going to be important that I don't forget? Line up what? Decimals. Because in 6, where is there a hidden decimal? After it, and add that 0. Very good. I'm just reminding us all of those things. When I subtract, I need to regroup. 5 and 10. 10 minus 6 is 4. Drop that decimal, and 3. Again, is it positive or negative? Positive, because there's more positives. Okay? Just a refresher. It's in a minute. And lastly, when the 5 and the 4 are next to each other like that, that means, and that answer would be 20. Very good. Any questions on this kind of stuff? Yes? No? Yes? What's your question?
Oh no.
Okay, great. All righty. So we are going to get into a lesson this week. Just a heads up, anyone, and this is important for recording too, who's missing tomorrow's lesson because you're going on a Canadian trip? Okay, it's going to be very crucial, like super important. Like if you do any makeup work, I'm saying I'm most important. Math's lesson tomorrow is going to be very imperative. It's going to be very important that you watch the lesson, and it's because it's spicy stuff. It's a little weird, and it's harder to jump into some of the stuff that we do. It's easy to jump in, and you'll be like, tomorrow's lesson, I encourage you to watch it, even if you're confused, because it's better than nothing. Okay, so please put that at the top of your priority list. Okay, but of course, I'll catch you up in the education report. All righty, this week is a very heavy on the 7th grade material stuff, and so that's why I say that, because tomorrow's 7th grade material is a big lesson, more important complicated. But we're sort of getting started on it today. Today we are talking about the constant rate of change. Constant rate of change. Okay, it's exactly what it sounds like. Break it in half. Rate of change, the rate at which something is changing. If I charge $5 a week, it's going to be 5. It's going to increase by 5, right? That's the rate at which each week changes. Does that make sense? Rate of change. And then if it's constant, I always charge $5 a week. It's not 5 and then 7 and then 12 and then 1. Okay? Constant means it stays the same. So constant rate of change is talking about a ratio. And that ratio is looking at the change in the dependent variable, change in the dependent, and we're going to compare that to the change in the independent. Change in the dependent versus independent. Dependent versus independent. Okay, let's do a quick review. Dependent variable, that's talking about X or Y. Y, okay, so that's the change, if you remember, we thought I like to use that triangle. the change in y versus the change in the independent, which is my x. Okay, change in independent. Okay, the letter that we use a lot of times, we talked about how x is often our input, y is our output. The letter M we use for our rate of change. Okay, the letter M we use a lot of time for our rate of change. We use the abbreviations. Okay, Miss Lyle's going to use lots of letters and symbols because she doesn't want to write it all out. So rock, rate of change. That is my M. Again, the rate of change is calculated with a ratio. That ratio, which of those would go on top? Change in y or the change in x? The change in y will go in over the change in the x values. Okay? That M, we've actually seen before. That is our multiplier. Remember how we talked about additive versus multiplicative relationships? The slope, the rate of change, that is our multiplier. So when we have the equation y equals like mx, it is my multiplier. That's my rate of change. Now good? So let's sort of do a practice one. The way that we find the rate of change, we're actually going to tweak it a little bit from how we looked at multiplicative before. I'm actually going to look at that change in y. I'm going to look at my y column, and I'm going to figure out what is changing each time. What is changing when I go from 0 to 6? What's happening? Plus 6. Is that happening always? Is it a constant? It is. Okay, so that change in y is equal to 6. Now we need to find the change in x. What is changing each time in our x? Plus 2, plus 2, plus 2. That's happening every single time. Y'all good with that? Yeah. Okay, what is 6 over 2 simplified down to? Just 3. So my slope, or sorry, my rate of change is 3. My rate of change is equal to 3. And again, that's going to go in place of that in. Okay, so I can write the equation 3x. Does that work? Now going back to like the side to side, if I did 6 times 3, is that 18? Is 6 times 3 18? If I put in 6, do I get out 18? If I put in 2, do I get out 6? Yes. Okay. It's looking at it differently. It's because something's going to change tomorrow, and that's why we're doing it like this. Okay. Let's do one more. The M stands for my rate of change, and to calculate the rate of change, I find the change in y over change in x. Okay, let's find that change in y. What happened? Plus
1.
What happened?
Plus 7.
Okay. What happened?
Plus 9.
Plus 9. Okay, so that doesn't mean anything, because if it's changing over here, that could still be constant, but let's check. From 0 to 1 is
1.
plus 1, 1 to 2. I don't have a good feeling. So let's just check. If I put that change in y, let's do the first pair. The change in y was 1 over the change in x was 1. What does that simplify down to?
1.
1. But what happens if I do the next one? 7 was the change over 1. Does that simplify to 1?
No.
No. Okay. So is this a constant rate of change or no?
No.
Not constant. Sad face. Not constant. I'm sorry? Yes. So that B is like when we had when we added stuff before. Remember how there's additive relationships where we added from one to the other? That is what that B is for. Is it written right here?
Yeah.
Oh, or right here? Yes. It's just when we add stuff. Today we won't see it too much, but tomorrow we'll have problems where they take like additive and multiplicative and put it together. So the M is like whatever we multiply by, and then B is going to be whatever we add. Okay, but starting tomorrow we'll have like 2 set problems. You don't need to, not yet. Okay? Does it have a blank for it? Oh, okay. So let's fill that in. Sorry, my first. So B is going to be. Do y'all remember what? Do y'all remember how when we looked at it before with our additive and multiplicative, wherever it hit the y-axis, was what we added or subtracted. We looked at that like one day. Y'all remember that? Okay. We'll come back to it, but that is going to be our y-intercept. Y'all remember that y-intercept word? It's wherever it hits the y-axis. It's when it doesn't go through the origin, it's a y-intercept. Oh, yeah. Huh?
What did you look at?
There is an x-intercept, but we don't use it too much in our writing equations. It's still important, but not right. All right, so y'all go ahead and find the constant rates of change for those next two problems, right? Not constant if it doesn't have a constant. Right, pause and play when you're ready. Let's look. What did you find, Philip, for this first one? You got 12, so that change in y over the change in x, you got 12 over 1, which simplifies to 12. Do you agree, class?
Yes.
Yes, and so you can write y equals 12x. Again, right now, we don't have anything that we need to add or subtract in there, so it's still just a plain multiplicative relationship. Okay, over here, who would like to share what they got? Bruna?
X minus 15.
I would disagree. It's close, but not quite right. Trigger?
Y equals negative 15x.
That is correct, and there is a difference, okay? Because in the way that you said it, at least, it sounds like you're subtracting when it should be multiplying, okay? But let's look. What's happening each time is it is subtracting 15, and so that's where you were getting it. It is, and then plus 1, it's minus 15, and plus 1. You can have a negative rate of change as long as it's constant. That change in y we said was subtracting 15. That change in x was positive. That simplifies down to negative 15, and we can plug in a negative 15x. Are we good with that?
Yeah.
All right. Yes, sir.
Do we need to put parentheses over with
The negative 15? You can, but don't have to. Since there's nothing before it, you don't have to differentiate with negatives at the front of the sentence, at the front of the equation. But you can always put it in. It makes you feel comfortable. All right, so we did a table. Now we're going to look at a graph. As you've already heard Miss Little slip up and say, constant rate of change is also called the slope. Have you all heard that word before? Okay, some people have from like older siblings or parents. Slope is a big algebra word. Okay, and it's going to be like the central focus of a lot of algebra is finding the slope. So we start whispering it in your ear now, so that when you get there, you're like not caught off guard. Okay, rate of change is the same thing as the slope. Why is it talking about that? Okay, when we find the slope, again, it's the same thing as the rate of change. We said we find the change in y over the change in x. Okay, let's look at that on a graph. If I'm looking at the change in y, I'm looking at how much it's going up and down. I'm looking at how much it rises. So you might hear that the rise is the change in y. Okay, another word for the change in y, another way you could think of it is how much does it rise. Stop. Okay, change in x is how much it's changing side to side, which is my run. The change in x is the same thing as run. So some people call it rise over run. Okay, and if you'll notice, if you remember those graphs, like the scrapbook, we were talking about graphing. Remember how it was always over 1, up 4, over 1, up 4, over 1, up 4. Since it's going at that same slope, it's a constant rate of change. If it was like plus 4, plus 7, plus 8, that would make it not linear and make it look all jagged and whoop. Okay, but linear means that it has a constant rate of change. Okay, let's actually calculate it. What's that change in y? From here to there. What's that change in y? It went from 6 to 12, so that would be plus 6 over my change in x, or my run side to side was, it went over 1, plus 1. That simplifies to just 6. My slope or my rate of change is equal to 6. Still good with that? Okay, again, it went up 6 and then over 1. The rise over the run. You want to try that next one? Go for it. Try it. All right, what did you go get? 2 over 1. The change in y, or that rise, it went up from 3 to 5, it rose 2. That change in x, how much it ran, it went from 1 to 2, so that would be 1. That simplifies down to 2. M is equal to 2. Y'all good so far?
Yes.
Okay. Last little bit, I think, on the next page. Not much left. Okay. So I just talked about this. Remember how a constant rate of change always forms a what kind of relationship? I said it makes a linear. Okay. Again, a big hint is if it's not linear, it does not have a constant rate of change. It's changing rate. The line depicts a constant unchanging ratio, and that line is called the slope of the function. How steep is that slope? With linear graphs, we can use any 2 points on the graph to find its slope. Again, the slope, we say is the change in y over the change in x. You're going to hear myself say this 6,000 times because I want it to stick in your brain. Okay, but a more fun way, if you can't remember which letter goes where, you can always think of it as rise over run. Okay, and then from there you're saying, oh, rise, that's up and down, so that's my change. Okay, again, as it mentions, I can pick any 2 points. It does not have to be 2 points that are right next to each other. It's Lila's going to rebel, and she's going to pick the first point and the last point, and prove that's the same thing. YOLO. Okay, what's that change in y? What's that rise? 27. And then what was my run? 3. What is 27 over 3 simplified down to? 9. There you go. All right. Would that be the same as any other points? Like if I picked 1, 9, and 2, 8, is it rising 9 and going over 1?
Yeah.
It's the same thing. Same thing, it does not matter. Go ahead, do the next one, pick any 2 points. Be different than your neighbor. So, what did you get, Ari? 60, do y'all agree?
Yeah.
Okay, any 2 points. Ari, what 2 points did you use? So you did this one, and, oh yeah, so that point, and then which other one? You have to use 2 points. 3 and 20. Oh, 120 and 2. Okay, so that change class was, if I went from 120 to 420, that would be a change of 300. If I go from 3, okay, so let's do that. 420. Pause. Okay, this is going to look a little different. So, if I'm trying to find that change, I went from 420 to 120. What is that change? 420 minus 120 class is 300. Okay, my change is x. I ended at 7, and I'm finding minus 2. That change was 5. Oh my gosh, give me a second. More talking. Oh no. Oh no. 1 second, guys. Alright, okay, so again, in finding that change, I'm finding the difference between 420 and 120. That was my blue up arrow. And then my change side to side, I'm ending up at 7 to find the change I'm subtracting those 2 values. So we said 300 was my change y, 5 was my change in x, and that can simplify to 60. If you had picked any 2 points, it ends up being 60. Yes, ma'am? Yes. Yes.
Why does it say y equals mx plus 3?
So again, we're literally about to get to that. If you see in my little notes, it's literally coming up next. Okay. So there's a relationship. So last week in the past 2 weeks, we talked about additive relationships exclusively versus multiplicative. Additive versus multiplicative. We always talked about the differences between them. What we're going to do now is we are going to combine the two. Okay, we are going to start seeing equations starting tomorrow where it's both additive and multiplicative. It's neither one or the other, it's a mixture of the two. So what that equation, remember how we had like parent equations where it was always like y equals kx, where you're multiplying, or y equals x plus a. It was your parent equation. the parent equation for these two-step problems is y equals mx plus b. Okay, that parent equation for these linear equations where it's taking both y equals mx plus b, where m is talking about my rate of change, my multiplier, my slope. It has many different words. That m is my multiplier, and then b is whatever I need to add. Okay, like my additive relationship. We talked about it sort of last week. So again, m is talking about my rate of change, and then my b is going to be talking about my y-intercept. Okay, we're going to go more into the y-intercepts tomorrow, but we're taking it step by step. Okay, so you'll notice that this, y'all have star charts on your desks or you pick them up. We'll notice that this equation, this parent equation, is on my star chart. It is not one that you have to memorize. I will let you know you will use it so much in life that you will memorize it over time. But just know that this linear equation is on there. It's called slope-intercept because it has the slope part of the equation is the slope, the other part is the intercept. Does that make sense? Yeah. Okay, again, we just need to remember the letter M stands for my rate of change or my slope, my multiplier, and my B is my intercept, my y-intercept. Okay, last little bit, and then we'll be good to go. The table shows the relationship. This is like a word column, slope, intercept, and a word column. It says the table shows the relationship between the number of seconds, y, it takes to hear thunder after lightning strikes, and the miles, which is x, you are from the lightning. We want to graph the data and determine the slope, explain what it means. We want to know what the numbers are actually talking about. So when I find the slope, we find the change in y over the change in x. Okay, I'm going to skip this, and we'll come back to it. What is that change in y? What are we finding each time? Plus 5. Change in y, again, I'm looking at my y, is plus 5, do you agree? Yeah. Okay, and my change in x is plus 1. So I'm going to put 5 over 1. Oh, no. So actually, sorry, it tells me what to use right here. It tells me to use those 2 points. Ooh, okay, so let's see if that changes anything. It tells me to use 315 and then 525. So if I'm finding the change in y, what's happening there? Plus how much? 10. And what's the change in x? Plus 2. So if I plug that in, it would actually be 10 over 2. What does 10 over 2 simplify down to? 5 over 1 or just 5. Okay? Now what goes in here is just a way to find that change. Whenever we find the change, we're finding the difference. If I was finding the difference in my y values, what I could write in this place is 25 minus 15. Because that's sort of what we're doing in our head. What is 25 minus 15? 10. And that's where we're getting that. This is just a mathematical step to get there. To find the change in x, we're going from 5 to 3. We said that change was how much? 5 minus 3 is 2, which is right there. Okay, it's just showing that in between step of what we're actually doing. Okay? The slope or the constant rate of change, we said, is 5. And we want to put some units with that. Okay? That change in y, that's talking about my seconds, and this is talking about my miles. So what it means in translation is for every 5 seconds between lightning, for every 5 seconds between lightning flash, the sound and the sound of thunder, there is 1 mile, because that's what we simplified to. For every 5 seconds, there's 1 mile between you and the lightning strike. Have y'all heard about that before?
Yeah. I don't never.
You can. Some people will like count how far away it is.
Weird.
All right. So, we're going to see if we have time for a Kahoot, but your homework is this page right here. It says what you're determining the constant rate of change or slope, same thing. You're finding the rate of change or the slope for each one. If it doesn't have a rate of change or a constant rate of change, we write not constant. Okay? Yes. What's what? Oh, we know that M is the slope. Sorry about that. Alrighty, that is it for today's recording. Please check your key.